Hello and welcome to Mr. Linford's math course. In today's discussion, we're going to be continuing our previous topic of exploring the different ways of factoring polynomials. In particular, we're going to go back to an older technique we had, the technique of grouping, and we're going to try to look at a more alternative way of grouping four-term polynomials. We're going to first go over what the problem would be that we need to address with this new form. We're going to look at when to use this new form of grouping and really explore what it is. So first, the problem is we want to factor the polynomial x squared minus y squared minus 6y minus 9. Well, this is a four-term polynomial. You should be having alarms go off in your head and recognizing that four-term polynomials require grouping. So we can group this down into x squared minus y squared plus a negative 6y minus 9. And we can start trying to find what the common factors are. Well, there really isn't a GCF in this problem, is there? It's just a 1 with an x squared minus y squared. And then here I could factor out a negative 3, so I'm left with y plus 3. I'm sorry, 2y plus 3. But this doesn't actually help us. Look, we have different binomials. So this is one of those problems where the grouping method doesn't seem to really work. Well, it's not that the method doesn't work, it's just the way in which we did the grouping doesn't work. In previous techniques with grouping, we grouped the first two terms and the last two terms together, hoping that we had a common binomial that was distributed through. Instead, what if there was a different setup to this problem? When it comes to the alternative form of grouping, we're going to use this after we first attempt to group like normal. Most cases, you can factor four-term polynomials by standard grouping. But if that doesn't work, we need to re-examine the problem here. We need to see, is there another form embedded in this problem? Hopefully you notice that actually a y squared, a 6y, and a 9, that seems to look like a trinomial, doesn't it? What we're going to try to do is group the polynomial by grouping, instead of a pairs of terms, we're going to try to group the trinomial together and attempt to see if what we group together can be factored down. So we're going to end up with an x squared plus, and then let's list the trinomial that we have. It is a minus y squared minus 6y minus 9. Now, I don't know about you, but I don't like negatives, so let's factor that negative out. We end up with an x squared minus a y squared plus 6y plus 9. Again, you could redistribute that negative through, but you would see this is what we end up with. So we've grouped together the trinomial values. Now we have to factor this trinomial. Our hope with grouping, really, if we do the original form of grouping or this new alternative form, our goal is that what we put in parentheses can be factored down. Originally, we hoped that we can factor out a GCF. Well, we saw that didn't work here. What we're now hoping to do is we're hoping that this can break apart. So let's see what we end up with. We still have the x squared minus, but this time we have the binomials, y plus 3 and a y plus 3. You can use box method to verify that for yourself, but 3 times 3 is 9, and that's going to add together to get you 6. So in reality, what we essentially have here is an x squared minus a y plus 3 squared. We have a quantity squared, and we have another quantity squared. This fits the form of the difference of squareds. We have two quantities squared, and they're being subtracted by each other. So we can factor this component down by using the difference of squareds formula. Let's go ahead and let's identify what's A and what's B. A in this problem is x, B in this problem is y plus 3. A and B are the quantities that are being squared. We're first squaring an x, then we're squaring the y plus 3. So if we use the difference of squareds formula, we end up with x plus y plus 3, and then we have x minus y minus 3. These are our final factors. Notice, please notice that I'm actually distributing the negative through here, okay? This is really of the form, the difference of squareds form, where we have a plus b and a minus b. Well, I'm subtracting all of y minus 3, so that's why I distributed the negative. Hopefully you're seeing how this is working. Really, you have two methods now for grouping. First, attempt to group like normal. And if that doesn't work, hope that this method does. This method says, okay, instead of grouping pairs together, we're going to try to group a trinomial together. And then we hope that that trinomial factors so that we end up with a difference of squareds. Will that always work? Not necessarily, but these are the two methods that we can try to use. So when do we go about using this technique? We will use this, again, for a 4-term polynomial. Always use it for a 4-term polynomial. That's really what grouping is for. Now, again, this is mostly used if the original method fails. So you can try these two practice problems. I want you to pause the video. You can first attempt to see the original method, see if they work, and you'll notice that the original technique doesn't work for either of these problems. Instead, go ahead and try to do the alternative method, where you try to group a different set of quantities together and factor them down. So pause the video, try to do the factoring, make sure you get to the very final answer, and then we'll check back in once you're done. All right, well, hopefully you were able to work through these problems and recognize that we want to group together the things that form a trinomial. So we're grouping together the things that have the same variables and the number, because those are the things that we can factor down. We're easily able to factor the first one down into x minus 3 times x minus 3 minus y squared. So we said, well, the a here is x minus 3, and the b here is y. So we're able to get x minus 3 plus y and x minus 3 minus y. Again, this just fits the form a plus b times a minus b. Now, the next problem, we're going to group together the trinomial, the things that have the a's and the number, and we can factor this down. This can be factored down by AC method, if you'd like, or you can try to do the box method. I sort of did the box method in my head, and I came up with the factors 2a plus 3 times 2a plus 3. So we really have b squared minus 2a plus 3 squared. So in this problem, the first thing being squared is the b. The second thing being squared is the 2a plus 3. So I'm going to set up the first thing plus the second thing, and then the first thing minus the second thing. So b plus 2a plus 3 and b minus 2a minus 3. Again, notice that I'm distributing that negative through, because when we distribute that negative through, we're essentially saying we're subtracting the whole thing, not just part of it, the entire thing. So this is really the alternative form of grouping. It's another method you could utilize if you're going and trying to figure out how to break down a 4-term polynomial, and the original method doesn't work. So here's an alternative form for you. Now, if you have any questions about this or any comments about the video or want me to go over more problems, feel free to let me know. My email is klinford, that's KLINFORD, @wccnet.edu. And until next time, take care.